If you've been following me on social media, you've probably spent a fair bit of your time lately feeling bad for me about all of the SSDs that I had to mount in our new 24-drive solid-state storage server. No? Alright, well then you've probably at least been hoping that I'll make a video about it at some point and talk about the performance. And that time is now. This is the all-new Wonic, the fastest beast machine in our office. The Corsair HX1200i power supply delivers 80 plus platinum efficiency for quiet performance and Corsair Link digital advanced monitoring and control. Click now to learn more. So our current storage server, Ruskin, uses Seagate 3TB consumer drives in a RAID 6 array to achieve respectable read and write performance and some fault tolerance. The array can actually lose up to 2 drives before suffering catastrophic data loss, assuming it's able to rebuild before more drives fail or an unrecoverable error occurs. This is all fine and good, but the main problem with it is that Ruskin was built for one editor to work on 4K video files at max speed, and we now have a whole room full of editors. So while the Ruskin 10 gigabit network interface and sequential data speeds aren't really bottlenecks, its mechanical drives are much more suitable for a single-person workflow. So I reached out to our good buddies at Kingston with a crazy idea. What if we slipped free of the surly bonds of mechanical storage and danced the skies on SSD's silvered wings? To which they kind of went, how much silver, Linus? I told them I wanted 24 1TB class drives, and doggone it, for some reason they said yes. I think the most incredible thing about that story is how much the landscape has changed in such a short amount of time. 2 years ago, I could have been the Pope in Rome, and any SSD maker would have laughed at me for wanting 20 terabytes of redundant SSD storage in a single server. But in 2015, Kingston's just like, yeah, we've got the enterprise-grade KC310. It's got an 8-channel Phison S10 controller, 960 gigabytes of capacity, ECC flash protection for data integrity, power loss protection, trim support, although we'll be relying on idle garbage collection in RAID anyway, and it's under 60 cents per gig. I mean, holy balls, I'm actually wearing the right shirt for that. So let's talk upgrade process then. The first thing I needed was way better RAID cards. Yes, cards. Not a single card. There are 24-port controllers. In fact, the old server has one, but since each individual SSD is capable of 500 plus megabytes per second read and write speeds, if you hook 24 of them up to a single card with a theoretical total speed in the neighborhood of 12 gigabytes per second, you're going to run into some pretty serious bottlenecks all over the place. So after removing the placeholder mechanical drives from the system, laboriously mounting 24 SSDs on sleds, and connecting the SFF 8087 connectors, each of which handles 4 drives, to their backplane in my Norco RPC 4224 chassis, man I love these things, on Kingston's recommendation, I picked up 3 LSI 9271 8i 8-port RAID cards, each in a PCI Express 3.x slot. This is where the X99 platform really shows its value because you're going to need enough PCI Express lanes to handle all that storage bandwidth, something that consumer-grade platforms simply cannot provide. Now, something a lot of people commented on when I posted a picture of these cards on Instagram was that these cards run really hot, and I had them installed right next to each other. Don't worry, I'm using a 90mm fan mounted directly on top of them for auxiliary cooling, and I'll be bolting that in before I install this server in our fancy rack cabinet at the new office. So with all the drives installed, the next step was getting firmware updates and drivers taken care of for my controllers and configuring arrays. Naturally, the first thing I did was throw the whole thing in RAID 0 for lols to see how fast it would go. There's a bit of a special process for this in this case though. You need to create a RAID 0 array of 8 drives on each of the controller cards, then use software RAID to put them all together. So in my case, that required the use of disk management in Windows to set each RAID 0 as a dynamic drive, then stripe the whole thing together. So it's kind of like RAID 000 or something like that. The results were, well, if Shania were here, I guess she'd say that don't impress me much. Read speeds were great. Even for 512K transactions, I'm looking at over 5.5 gigabytes per second. I mean, remember, this is for video editing, so very little of what we deal with is going to be smaller than half a meg. With 4K transfers, that's more than 2 full orders of magnitude faster than my old 10 hard drive solution. But those write speeds aren't enough to saturate the planned 2 by 10 gigabit Teams network connection the server is packing if multiple users are writing large files to the array. Either way, RAID 0 wasn't my final configuration since I wanted some fault tolerance, so I figured if I'm going to troubleshoot this thing, I might as well do it when it's set up properly. So I threw my 8-drive arrays in RAID 5. That allows me to lose up to 1 drive per array, and then I also have a spare drive on hand in the unlikely event of a failure, which is lots for a server that'll be backed up nightly on the network. Then I striped those RAID 5s together in software for what is effectively RAID 50. A quick benchmark before the arrays were finished initializing revealed worse numbers than RAID 0, although that's pretty much a given since any parity RAID puts much more load on the controller card, especially for writes than a striping RAID, but I really hadn't expected them to be this bad. So I waited for the arrays to finish initializing, and they got worse. So it was about that time that I realized maybe the write cache setting on solid state makes a bigger difference than on mechanical. So even though I don't have battery backups for my cards or a UPS for my server yet, I enabled write back cache, and there we go. There is the drawback of an unexpected power loss causing potential data loss with write back caching enabled, but we're just going to have to get those batteries and UPSs going because with that setting on, we are able to saturate the bananas out of any connection we can make on the network to this server. When she's handling large streaming reads and writes, this array can do in excess of 5 gigabytes per second. When she's handling extremely small transactions, she can still do just under 100 times the performance of Ruskin. And when she's able to queue up those small transactions from many clients hitting her at the same time, she can do well over 500 megabytes per second. I just need to drop another $600 on battery units for the RAID cards and wait for the network cards for my clients to show up so that I can show you guys how the network is going to handle all of this. Man, this server grade stuff is expensive and very time consuming, but it floats my geeky boat to see numbers like this, where a PCI Express based Predator SSD is the bottleneck in a local file transfer. Speaking of stuff that floats my geeky boat, iFixit. You probably know iFixit from their teardowns of electronic devices and their fantastic repair guides on their site that can save you tens, 50s, even hundreds of dollars on repair costs. I've used them a number of times on an iMac, on a phone, and I'm sure there's something else, but I'm not thinking of it at the moment. What you probably aren't aware of is that iFixit sells professional grade tools as well. So they've got their iFixit 54-bit driver kit. They've got all these little prying tools. They've got anti-static straps. They've got their magnetic organizer that I might have handy. Yep. I was using this the other day that lets you write little labels, draw little diagrams, and keep all your screws somewhere safe when you're working on a project. They've got all kinds of fantastic stuff, whether you're trying to take apart a Nintendo DS with a tri-wing bit, whether you're trying to take apart McDonald's toys with a triangle bit, or you need to take apart something that uses security Torxes. All that stuff, they've got it. And what's cool is when you go on their guides, they actually list all of the tools that you need for a particular guide. The one to probably start with, though, is the kind of all-in-one ProTech Toolkit pack. I use mine all the time. It's $65, and if you use ifixit.com/Linus and then code Linus05 at the checkout, you save $10 off that or any purchase of $50 or more. So it's ifixit.com/Linus. Check it out. Great tools, great guides, great stuff. So that's pretty much it, guys. Thanks for watching. Like the video if you liked it, dislike it if you thought it sucked, leave a comment, preferably at the link below to our forum if you want to discuss it. Also linked below, you can buy a cool t-shirt like this one. You can give us a monthly contribution if you think what we're doing is important. You can change your Amazon bookmark to one with our affiliate code, so next time you buy 24 SSDs, we'll get a kickback from that. And that's pretty much it. Don't forget to subscribe and follow and all that good stuff. Thanks again for watching.